use Euclid division lemma. So they want us to use that to show that a cube of any positive integer, any means, again, we're talking about all the scenarios, is of the form 9m, 9m plus 1 and 9m plus 8. So we are looking at all the numbers, all positive integers, not even or odd, all possible integers, but cube of it. It will obey a pattern 9m, 9m plus 1 and 9m plus 8. Okay, so let's look at it using our coding. So we have divisor is 9 in this case. Okay, and then we are cubing it. So here I'll cube it, right? This is how you show that we need to cube the given set of numbers, and then I'll show the pattern of reminders. So just a minute. Okay, so let's see that, right? So the question was 9m, 9m plus 1 and 9m plus 8. So that's the question, right? Let's verify that. Yes, 9m, 9m plus 1 and 9m plus 8. So that's what we got. So the pattern is right. The question is right. Obviously the question is right, but yeah, we saw the pattern as well using our coding. Okay, so the heading of this particular graph will be, the topic will be reminder of cube of numbers, right, on dividing with 9. Okay, so this is your scenario, right? So we are looking at 600 to 640, and we can clearly see the pattern is 0, 1 and 8, 0, 1 and 8, but they are in a group of 3, 0, 1 and 8. So we can handle this question in a smarter way, right? When we are doing it mathematically, we will see. So if you want to understand this particular pattern and if you want to verify this at home, what will I do is I'll execute for you guys from 3 till 43. Okay, so then you can see the graph yourself and then make your conclusions. So you can pause it over here, take number 3, cube it and divide by 3. You can use a calculator also. Take the number 4, cube it and divide by 3. You'll get a remainder of 1. Take 5, cube it, divide by 3. You get a remainder of 8. So, sorry, not 3, 9. Divide by 9 and you get a remainder of 8. Okay, so that you guys can do on your own. So next, the proof. How does this work? And not how does it work, sorry. Proof of that, yes, you take any random integer. This was just few specific case, but you have to show it for all the integers. For that we need to make use of Euclid division lemma, right? So as usual, you need to write that big statement as per Euclid division lemma. If A and B, where A is greater than B, represents all possible positive integers, then I can always write A as B into Q plus R, right? Plus R, where R is between 0 and then B, right? Where Q comma R are unique numbers, integers actually, unique integers, right? So there's a trick to this question. We saw the pattern of 3, is it not? Right? This has to do something with 3. So what I can do is I can substitute in place of 9 I can substitute b is equal to 3, right? Then the reminders also will reduce and your answer it will be not so lengthy. Okay, so let me show that. A is equal to 3q plus r, where r is greater than or equal to 0 but lesser than 3. This implies reminder has to be 0 or 1, if not 2. Okay, now I will cube, right? Cubing both, or taking cube of both the sides, cubing both sides. I actually don't know if the word cubing makes sense. Taking cube of both the sides, that I think we should write that. You guys can web search if the word cubing is actually there or not. That's your homework. I know, stupid homework. So a cube is equal to 3 cube plus r the whole cube. See, the point here is a represents all the integers. That's the whole idea, right? And a cube represents the cube of all the integers. So what pattern will it end up with is a pattern. It doesn't matter what you started with. Main thing is you will end up with that pattern. That's what we have to show, right? So here we are using again a plus b the whole cube. I think I can do a better job. A plus b the whole cube, which is nothing but a cube plus b cube plus 3ab into a plus b, right? So this will be, oh yeah, I mean this is the formula that we are using. Actually, my bad, I expanded it instead of writing the formula. This will be a plus b the whole cube is a cube plus b cube plus 3ab into a plus b. Again, one request, if you are not getting all of this or if you don't know all of this, please watch my math basic videos, learn all of this and come to your syllabus math. Now expanding the right hand side, we will be getting 3q the whole cube plus r cube plus 3 into 3q into r into 3q plus r, right? We need to further simplify this. 3q whole cube is 27 q cube. I'm doing it here fast because I've done the basics in math basics, so you need to learn those. I'll just rearrange using commutative law, right? And I'll write the r cube at the last. Okay, so again, commutative law, all these words I taught in where, yes, I taught in your math basics. So between the first and the second term I have 9 common, so I'll be left out with 3q cube. Here we have qr 3q plus r, this is your left out, right? And 9 is common plus r cube. So this entire thing I'll call it as, let n be equal to 3q cube plus qr into 3q plus r. So you have, therefore we have a cube is equal to 9n plus r cube. That's your pattern, right? It's similar to what we want. See, it became so easy now. As usual, we have different cases. Case and the remainder is 0. See, the remainder I told you, just because cubing the expression, the remainder will not change, right? So we need not cube it basically. So when we have the remainder to be 0, the cube of that number will end up with a pattern of 9n. Again, n, m doesn't matter, it's just a variable. Case when the remainder is 1, it is a cube plus is equal to 9n plus 1 the whole cube, which is 1 itself. That pattern is also valid. And we have case when we have r is equal to 2. So here you get a bit weird. Oh, no, actually 2 cube. So this is 9n plus 8. Oh, this is what we wanted. Done. Right, we get a pattern of 9n plus 1 and 9n plus 8. That's what we got, right, in the graph also. 9n plus 1, 9n plus 8. Right? So that's what we wanted and that's what we got. So this is correct. Please enroll to our program at chalkpieceacademy.com, wherein we'll be teaching you a lot more tricks for faster simplification and calculation, DIY projects. We'll code with Python. We'll work with Arduino Uno. There are a lot more magic tricks and the physics behind it. There are printable materials which will help you recap and understand things better. We'll have live revision and doubt session 2 months before your term exams. It's very cost effective. There would be no ads or any kind of distractions, and we have a dedicated app to help you guys with this.